Hello, another little project, quite a simple one, and it's a LED sequencer, which is very adjustable depending on the speed you set the two oscillators at, and whether you have it reset at the end of a filling sequence or just keep filling and emptying. So that's more or less emulating a car indicator type signal. If I turn the cycle rate up, it'll shorten the fill. Turn the cycle rate down, it'll stay on longer. If I turn the fill rate down, the clock, you can turn the whole thing down. If I disconnect the reset line, it'll fill and empty sequentially as well by controlling the two speeds. If you match the speed so it's about filling and then immediately emptying, I get that right. If you go a bit faster, you can have a half fill or multiple segments. I'll slow the clock down so you can see what's happening better. So you can get quite a range of patterns. It's an interesting thing to play with, and it's got some uses for directional indications or just a novelty, and it can be extended as long as you like. This is using two shift registers for the output stage. We just zoom out a bit or move it off this stand so you can see the whole thing into the pile of component boxes. Right, so that's the whole setup. Two shift register ICs, which I'm using HC595s, 8-bit shift registers, and there's a lot more mess and wiring on here because it's on breadboards than you'd actually need if you're building it on a bit of strip board or something. So they go to a lead and resistor, which could be in either order. I've done the resistors on the edge just because of spacing, it's more convenient. And then this is the control circuit, if you like, which is a 4093 set up as two separate astable oscillators. The one at the top, which is all the orange wiring, is the cycle rate. That feeds the data input to the shift register, so that's controlling when the lights start going on or start going off. And then the other one is the clock rate to the shift register, which sets how fast things scroll through it. I'll turn that right down. So a range of patterns, and depending on the combination you get different effects depending on the ratio of the two. And if you link the cycle output that feeds the data input to the reset on the shift registers, which have got held by a pull-up resistor, so it's normally not active, the two are linked together across the shift registers. If you link that into that as well, then when the data line goes low, it clears instantly rather than cycling through. I put it in the wrong wire, I think. I have. That's why I stopped working. I've got it the wrong wire. Wrong pin. Right. That's a bit too fast at that for it to fill. So you can get the fill and then extinguish effect. Or more like a car indicator, where it's kind of fully on and then fully off for similar intervals. Oh, it's a interesting little gadget, and as I say, it's just shift registers. I'm using two 8-bit shift registers, And the only other components really from the oscillator are the leads, resistors and decoupling. It needs a decoupling capacitor occasionally. I put 2 in there because it's a breadboard, everything's spread out, and a single pull-up resistor for the reset line if you're not using it. But it could be made longer in multiples of 8 or as you wished. And I'll link the circuit. In fact, I'll show the circuit. I'll insert it. And there's a couple of other options I've not tried yet because I haven't got the parts yet. One is to use a 4060 IC, which is an oscillator and divider combined. If you use the first output from the dividers as the shift clock, then one of the later outputs, which could be say 16 or 32 times slower for the data clock, you could have a fill and then instant reset, or a fill and then stay on for at the same time and then a reset. And you can get, well, it's only a single IC, a single oscillator. It's not really much difference complexity wise, but it would mean that the pattern is exactly synchronous and fixed rather than being completely independent between the two. It depends what you want it to do. Now that's got the clock so slow, it's only barely filling at that now. Turn the cycle down appropriately. So it's too slow really, it's getting boring. Yeah, that's a slow fill. Yeah, it's more interesting if it's running a bit faster, I think. Anyway, you can see some of the ideas. So it's just a quickie video, and I'll include the circuits and a link to a PDF that's got some of the other ideas in it. You could also use 74HC164 shift registers. The wiring's slightly different, but it should work just the same. And interestingly, these LEDs are out of a big mix pack I got. I'm not quite sure where. It's something like 1,000 LEDs, and I used 470 ohm resistors to start to make sure they're nice and bright. And I'm just about blinding myself. These are now running on 10k resistors, so they're taking less than half a milliamp, and they're still quite bright. I've got actually the options for a couple more though. I'm not sure which way around these two are now, which is red, which is blue. But I did allow for a couple of indicators on here, just as a demonstration really, so it's possible to see how fast the various signals are running. And then you see that's the cycle signal that controls the data input or reset, and that's the clock input, which controls how fast the shift register moves through. Take the reset wire out again, so you can see it moving all the time. So you can see that each time that turns on, it moves through one bit, and it'll turn lights on as long as the cycle input data to the shift register is high, and turn them off when that goes low. So it's a very simple circuit, but it's just an interesting novelty, and it's a fairly straightforward thing to build as long as you've got a bit of breadboard and plenty of wires, or a bit of strip board. If you're going to use strip board, I would socket the ICs just for safety, because they are CMOS, they could be damaged by static if you're wiring them after soldering. Other than that, it's straightforward. Just make sure it's operating on about 5 volts, because 74HCs are voltage critical. They're not like 4000 series that will operate on higher voltages. So you do need a 5 volt supply, but other than that, it's just something to mess with and have fun. That's okay. So thanks for watching.